All right. So we have Dawson and Rod. And this is a question that involves a speed. Okay, so there's a little added layer of difficulty there. So we're told the speed and the direction of the path that Dawson is walking, right? Rod started from the same point and walked a little faster in a different direction. So it says calculate the distance between them after walking for 10 hours. So to find the distances that each of them walked, right, we would just go 2 kilometers per hour times, we would go 10 hours, right, for Dawson. And so the hours cancel out here. And so it's 2 times 10, which is essentially walked for 20 kilometers. And then there's 3 kilometers per hour times 10. So they would have to give you how much time has gone by, okay? And in order for you to know the distance traveled, so the hours cancel out, so it's 3 times 10, which is 30 kilometers here. Okay, so you have both distances that they each of them have walked. So this would be Dawson, and this would be Rod. Okay. So both going, one is going northeast and the other one is going southeast, so it's wise to probably start over here somewhere. Okay, so this is the starting point, and so Dawson walks north, so you start your dotted line and then you turn 40 degrees east. You're walking, and just make sure you put the 40 in here. Okay, and that's for 20 kilometers. Okay. Then Rod, so I'm going to make the stop here. I'm going to call this D for Dawson, right? And then the other rod is going to go south, and it's going to go 20 kilometers, sorry, 20 degrees here, right, for 30 kilometers. And I'm going to make sure that I don't line up with Dawson, right? Because the question does not say, you know, that Rod is walking until he is directly due south of Dawson, or until Dawson is directly due north of Rod. Like, there's nothing mentioned that they're perfectly lined up. So I'm going to stop it here. I'm going to call this R for Rod. And then obviously you have your triangle here, right? Formed. And so this is what they're asking for. It's our unknown. We have a side, and yet to find the angle in between, but you can tell that there's a straight line here, right? Because one of them started north and the other one south. So there's a straight line, you can find that angle, no problem. We can call this S for starting point. So let's go ahead and solve this. Angle S is going to be 180 because there's a straight line, minus 40 minus 20. And that gives us 120 degrees. Okay, so there you have it. Given that this is 120 here, I now have an SAS situation. Okay, now have SAS case, so we have to use cosine law here. There's no pair, so you have to use cosine law. So if you wanted to find x, right, x squared is equal to 30 squared plus 20 squared minus 2 times 30 times 20. And remember, cosine of an obtuse angle, this will be negative. So if you're doing this in steps, you gotta watch out for that. So x will be square root of whatever I get by typing that all in. And I get 1900 exactly. So x, if you take the square root of that, is 43.59 kilometers apart. Kilometers should have been inside the box, but so there you have it. Interpretation, right? Finding the 120, realizing that this is cosine law, and then solving. Okay. So let's do another one. Another example here. Sketch a triangle given that, right? So I give you an expression there which you should recognize. Okay, Amrinder, I'll mark you here. So if you're given something like that, right, you can assign, you know that this is a cosine law situation. You can just say, well, this is going to be side A, side B, side C, and therefore this one here, if I call this lowercase a, then this angle right here, the 60 will be capital A. Okay, so you just draw a triangle. It doesn't have to be drawn to scale. A, B, C. And you put the 60-degree in here for A. You put 6 there. You don't know what the units are. B is going to be across angle B, and 7 is going to be across angle C. And there you have your sketch triangle. Okay. And then I'm going to ask you to write down another word problem. Yeah. All right. I will go over this, and then I will assign trig review A to you for you to try. All right. Here we go. So Talia is visiting her friend at a cabin, which is located 3.8 kilometers in the direction south 28 east. So we're going to start our diagram. Are we going south and east? So we're going to start on the left side here, right about there. So this is Talia's place, right? We're going to call that T, right? And the cabin is located in direction south 28 east. So south, that's your dashed line. You're going to turn 28 degrees towards east and start your journey. They happen to tell you the length of that direction. That's 3.8 kilometers here. And that'll be the cabin, right? Friend's cabin. So after that, they plan to go to the beach, which is 4.3 kilometers from the cabin in the direction north 57 east. So you start from here, you make a dashed line towards north, you turn 57 degrees east, and you go out like that. And this angle is a little bit bigger than the 28, that's why it's turning that way. And I do not line up perfectly because there's no indication, right? So I'm actually gonna go a little shorter, or you can go past it if you want, right? It's probably more realistic to do that because it's 4.3 kilometers, right? There. So this is the beach, right? And it's asking how far is the beach from Talia's place. So as I'm saying, as you start making your diagram, it's gonna make more sense. Oh, it's 57, my bad. Yeah, yeah. Thank you. So as you start graphing, two things, right? It's gonna make more sense. Pieces are gonna start coming together, and secondly, you may realize that you have to erase and start over, and that's fine, right? Like there's nothing wrong with that. So here we go. Um, we need to find out the distance between Talia's place and the cabin, and the beach, sorry. So this is my unknown here. Okay, ultimately that's what they're asking us for. So when you have these compass direction type question, you want to try to transfer over angles by applying the parallel line properties that we've learned about. And you realize that this line here is parallel to this line here. This is your north and south lines, right? And so you can actually transfer that 28 over to there by using the alternate interior property, right? Alternate interior angles there. And then you get this angle here, right? Which is 28 plus 57, which is 85 degrees. Okay. That's fine with me, just you putting it down here and showing it there. That's all I need, okay? So as soon as you have that, now you have the angle inside the triangle. You kind of don't worry about this 28 out here, but you realize again it's SAS, right? So it's SAS, you know you need to use the cosine law. Okay, so here we go. X squared is equal to 3.8 squared plus 4.3 squared minus 2 times 3.8 times 4.3, and I'm going to run out of room. Cosine of 85. There it is. X is going to be equal to square root of 30.081 dot dot dot, and x ends up being 5.48 kilometers. So at this point, you have quite a few examples and different scenarios that could come up. And I'm gonna post a PDF as well of this handout I want you to work on. So there's mixed reviews A, B, and C. So the one I want you to work on today for the rest of today's class, and there may be some similarities, but they're different, okay? And so this is the one I want you to find, right? Trig review A, and use the rest of today's class to work through that. And tomorrow it's going to be B and C most likely. I put them together so that you do have a mix. Okay, so it's not just cosine law, it's not just sine law, it's both of them. So you basically just look at, do I have a pair? If there is a pair, it's sine law, done, you're done. Remember the hidden pair, right? And if it's an SAS or a triple side, then you know it's cosine law, right? That's how simple that is. So I'm gonna do trig review A, okay? And I have the answer key as well scanned, so I can post that in a bit, probably towards the end of the class. So just remain online just in case I have some remarks to make towards the end. But just use the rest of the class to work on that, okay? And I will also find a PDF and post that in case you don't have it, okay? All right.